In this problem, we're finding the volume of this composite solid. This solid is made up of a hemisphere, a cylinder, and a cone. So let's go ahead and let's write our action plan. So the volume here is going to be finding the volume of the hemisphere, which remember, that's taking half the volume of a sphere. Then we're going to be adding to that the volume of a cylinder plus the volume of a cone. So let's recall our different formulas. So for a sphere, that's going to be 4/3 pi r cubed. So we'll write here 1/2 of the volume of our sphere of 4/3 pi r cubed. Then plus our volume of our cylinder, so that's area of our base times our height. So that's going to be pi r squared h. Then we're going to have the volume of our cone, which that's going to be 1/3 the area of our base, which is pi r squared, times our height. So it looks like we need to find the radius, and each of these three figures are sharing the same size circle for either the great circle or for its base. And so we notice here that we're given essentially the diameter of that circle, and that's going to be 4. So our radius here is going to have a length of 2. So in these formulas here, we can substitute 2 in for r. And as we do this, I'm going to do our 1/2 of 4/3. So that's going to be 1 times 4 is 4, 2 times 3 is 6. So it's 4/6, which reduces down to 2/3 pi. And then we're going to put in our radius. So our radius here is 2 on each one of these shapes. So this will become pi times 2 cubed. And then for our cone then, we're going to have 1/3 pi times 2 squared, and then our height. Now what we have to be careful here is these heights for a cylinder and a cone are not the same. So we have to be careful when we do that. With our cone, or excuse me, our cylinder, the distance between those two bases there are 10. So that's going to be the height of our cone. For our, excuse me, our cylinder. For our cone, that's going to be this dotted line that's in there. And when we do that, we notice that we're given this angle here is 24 degrees. So I'm also going to draw in our radius. And we know our radius there is 2. And I'm going to also draw in our slant height there. So I'm going to pull out that right triangle. And we know that this is 2, this is 24 degrees. We're looking for our height. And so we're going to have to do our trig. So we have our tangent of 24 degrees equals 2 over h. And when we solve for h, we're going to get 2 divided by the tangent of 24 degrees. And then as our calculator, when we do that, we're going to get that to be approximately 4.5. So we'll go ahead and put that in there for our height of our cone. So since that one is a string of numbers in there, let's do that calculation here first. So you're going to take 4.5 with that string of numbers, times 2 squared, which is 4, divide that by 3, and then multiply that by pi. And what you should get there, you should get about 18.8. So now we do the same thing there for our cylinder. So we're going to have 10 times 2 cubed. Oops, I have a typo. That should be 2 squared in there. And that's one thing you have to watch for when you're doing your work, is when are they squared and when are they cubed. So 2 squared is 4, and then 4 times 10 is 40. So you take 40 times pi, and that's going to give you 125.7. And then for our volume of our hemisphere now, we'll take 2 cubed, which is 8. And then 8 times 2 is 16. And then divide that by 3 and multiply that by pi, or that's like 16/3 pi. You're going to get that to be about 16.8. And so now when we go to add that all together, we're going to find that this volume is approximately 161.3